Hi, well, it's Graham here, and I'm going to describe making the brake blocks for a Stirling single tender. There are a number of ways of making the brake blocks, and quite a few of the model locomotives that are available have castings for the brake blocks, but for the Stirling single there aren't any. So I'm machining them out of a solid. There are a number of ways of doing this, and there's a number of videos on YouTube. One in particular shows the use of a boring head, and the brake block is held in a boring head, held in a milling machine with a boring head, and this radius is cut. I'm going to do it slightly differently, and I'm going to use the rotary table. I've drawn out this on a CAD package, and the radius that we want to put in is 2.125, 2 and an eighth. The circle here simply represents the cutter. So the idea is we cut it with a slight angle, because the wheels are not parallel. There's a 1.9 degree angle on the face of the wheel. So what I'm going to do is to tilt over the Bridgeport head. I'm fortunate I've got a Bridgeport, and yeah, so I'm going to tilt over the Bridgeport head by 1.9 degrees and then cut this. Now the question is, how do you get this all set up so that you get an accurate radius? And of course it wants to be reasonably accurate. Well, the way I've done it anyway is I've had some aluminium. I've had it for ages, some scrap aluminium basically. And what I'm going to do is I've drilled a hole here for a peg which mounts on that, and then here at the root of the radius I put in a 1/2 inch hole. Now that I've got a clean memory card, I can carry on with the video. Right, where was I? Okay, so I think I'd said that this circle here represents the cutter. I'm going to angle the Bridgeport mill head over to 1.9 degrees or thereabouts. I've put this on a jig, so I have a hole in the centre of my fixture which has a spigot, if you like, that goes into the centre of the rotary table, and I'll show you that in a second. I have a pin here which is exactly 2.625, 2 5/8 from the hole, so that I know that the relationship between that and this, that and the centre, is correct. The only other thing you've got to do is make sure that this is tangential with this. So how do you go about doing that? Well, that's fairly easy. Just put a square across it, across the fixture. So this was my piece of the piece of aluminium. Going to have a hole here which plugs into the rotary table, another hole here somewhere for a peg which that fits in, and I shall show you. So the first thing I've done is, here's my bar from which I'm going to make the brake shoes. I've drilled the holes at the relevant spacing, and what I've done is allowed the thickness of, I've got a small bandsaw, the thickness of a bandsaw, so that when I cut these out it will take into account that thickness. I've actually machined the first one, whether you can see that. So I've got a radius there. Oh, I should have said the scale of this is 2:1, hence it's a bit big. Right, let's go over to the milling machine and see how this is set up. There's the milling machine table, and so what we've got in the centre of the milling machine, there's a Morse taper. I've put in there one of these Morse tapers you can buy online, which are fairly cheap, with a soft centre, and fitted a 1/2 inch piece of, it's actually stainless steel, into the centre of the hole, so that's bang on in the centre. I've aligned the Bridgeport head with the centre here, and I've got a digital readout, so I know exactly where it is in relationship to the centre. This is the peg where I fit the bar material for cutting the radius. So let's go about it then. So the first thing I shall do is mount my stock on this pin and get everything tightened up. So I'll just stop the video there and we'll come back to it in a second. I mentioned previously about setting this up so that we're tangential to the axis. So all I've done with that, I've got a small square, just set it up, align it with the square, and now just tighten up one of the nuts, which is good. That's probably enough actually, given the forces. I'm not taking off a huge cut. The total cut at the centre of the radius is 94 thou, so it's not a huge amount, but nevertheless if I can get another fixing on I will do so. And I'll just get that other clamp set on there and then we'll be ready to start machining. Right, we're all set up, clamps are on. Milling machine is set for, it's 500 RPM, so I've got it's a 3/4 inch cutter in there. And what I'm going to do is first of all just touch on the bottom, and I just want to take a couple of thou skim off the aluminium so to make sure that I'm all the way down. Anyway, we're ready to go, so let's try it and see what happens. So it's just touching the aluminium now. The cutter set up to give me the correct radius, so the milling machine is. Just starting to cut now. This would be better, I guess, with a proper full coolant system, but I haven't got that on the mill, so I'm just using some neat cutting oil, and with a sharp cutter it seems to be going pretty well. I've got a compressed air, I'll just flush some of this out of the way. And there we have it. That's the completed cut. And now I'll just work my way along and do the 6 of these in total that have got to be cut. So I'll do each of the 6, and then it'll be a case of going to the bandsaw, cutting them to length, and then I'll show you how we set up for the next cut. Right, that finishes the machining of the first phase. So I've got all 6 ready now. Next part is to cut these to length, and I've got a little bandsaw I'll do that on, and then we'll be back on the rotary table to machine the radiuses and the radiuses that fit on, that are here and here. Okay, so I've cut all 6 on the bandsaw. Not quite true, the very last one I had to cut by hand because I couldn't grip it. Anyway, so they're in the 6. Now the next challenge is, what we've got is a radius on this back end. So how do we cut that? And it isn't too difficult actually. Again, you just need a little jig. So we know that the radius is 1 1/4. Now if we were to mount this again in the right position relative to this, we can cut it in the same way. The tricky bit is how do you get it in the right position. well, a cunning plan here. So look if we can see that. I think just about. So imagine a piece of material that we can clamp this to. Here's my circle. From here to the centre, or in line, to the centre of this radius, could be in line. So the only other thing you've got to do is decide how on earth do you get this in the right plane. Well, put a peg here, and we've just machined this face, so we know the distance from here to here. Peg in there, and that will orientate the material in the correct position. And if I can just fix this up. So there is the bar. This is my mount for the mounting hole. And somewhere I've got another peg. So let's just see this. So put the peg in there. Hold that against there. If you can see that. And now if I cut from here with the right cutter, sorry, well, practically any cutter, I can get the correct radius, and that will be in the correct position because that there is tangential to the curve. That's what I intend to do. So rather than cut all of the material away on the milling machine, I think a better approach is to hacksaw some of it off and then use the milling machine for the final piece. And in order to do that, I've made a couple of buttons out of silver steel. This was one. This was a test piece I did earlier just to try things out. But what I can do with the buttons, so buttons on there. So look, can you see that? Yeah, buttons on there. And then draw a line from the button, because it's got to be tangential to the button, to the edge of the material, and just hacksaw that bit off, and then I'll put it on the milling machine. So now to do some hacksawing. So I've just roughed these out now with a hacksaw, and ready for the next stage of machining on the milling machine. I just need to pop the milling machine back up to vertical before I do that, and then we're good to go. So actually, just before we start machining, I thought I would show how on the Bridgeport you can reset up the head to be vertical fairly quickly. This is probably not super accurate, but it's not bad at all. And the mechanism, the method by which you do it, is to use the reference faces which are machined into the Bridgeport here and here. So if you've got an accurate square, which I think if you can see that, this one is pretty good. I've tested, I've looked at this, I've measured it as best as I can, and as far as I can tell this is accurate. So how do you go about doing it? Well, it's simple. Just put it onto a flat surface, something that you know is parallel to the vise. Sorry about that. Sorry, I said parallel to the table, and in fact this vise is parallel to the table, so just do that. And you can see very quickly that's less than a thou or so over what is quite a long distance there. So, and to adjust it, you just undo the 4 bolts, tweak the worm wheel in here, and it moves the head back and forth, but it literally takes a couple of minutes, no less than that, yeah, maybe just a couple of minutes just to get that back to vertical. Is it super accurate? Well, I reckon it's within 2 or 3 thou over that sort of distance, which for the purposes of most of the stuff I'm doing is adequate. Anyway, back to the machining. Right, we're set up on the rotary table. I can just move around slightly. You'll see that the brake block here is tangential to this peg, so the curved face is over here. Then if I just come around, you can see how I've got that clamped up, and we're ready to take the first cut. What I shall do is make sure I'm clear of the piece before we start machining, and then start machining. So let's have a look if we can do that. I've lightly touched the aluminium. I'm going to back it off a couple of thou or 5 thou, so I'm clear of the aluminium now when I start the mill. I shall start it now and then put back 5 thou, 6 thou, so I'm just touching the aluminium, and we'll do the cut. And I'm just going to make sure that the backlash is removed from the rotary table. That's the way. Right, start there. Just touching the aluminium, and now starting the cut there. And there we are, that's it. So the cut takes 30 seconds or so. The setup takes a little bit longer. Right, now the thing is, because this is symmetrical, I can simply... Right, the final piece on the machining on the rotary table for the brake block is to radius the end here. And I actually made a couple of filing buttons to do it by hand, but then I thought, well, I've got it on the rotary table anyway, why don't I just do it on the rotary table? And that seems to be quite a quick way of doing it. So here we go, and I'm just going to do it now. Bring that down. Cutter is still running the same 500 RPM, 3/4 inch cutter, high speed steel, and this is not having to take very much off, so the size of the chips are very, very small. And I'm only doing this by, if you like, eye and feel, so that once I get round to the other side, I'm just trying to get it to the point where it starts to blend with the other radius, which is just about there. And that's it. So it only takes a couple of seconds to do that. And that's the finished radius. And the only other thing I've got to do is cut a slot now in the tops of all of these. I think it's 1/8 of an inch, and I'll have to use an end mill for that, which is a bit unfortunate really. I'd much rather use a slitting saw, but at the moment I can't think of a way of holding that so that I can get a slitting saw in position to do it. Anyway, I'll have a look at it and we'll see where we go. Now cutting the slots in the brake shoes. Got a 1/8 of an inch cutter, and it is moving at just about 2,750 RPM with a feed rate of 4 inches per minute. A bit more. The depth of cut I'm putting on is 40 thou each time. So size 14, just winding the depth of cut up now. It's a 2-flute slot mill, and because of that I can cut really in either direction. So I'm now coming back. I'm just using some neat cutting oil. Because of the small diameter, I'm only taking, as I say, 40 thou cuts off each time, which means we need quite a few passes. Just turn it off for a second. Not sure whether you can see the setup here, but what I've got is a parallel, which this is sitting on, or these are sitting on, sorry, and then there's another parallel here which is used to grip this face. Unfortunately the parallels were very fractionally bigger than the size of the brakes. So in order to grip them safely, I've used another parallel there, and it's holding it roughly in the middle. So that seems to be a very secure setup. Right, let's carry on.